All right, so today we are going to also look at slope fields, and they can help us approximate solutions of differential equations. Again, the last two classes we worked on separation of variables, where we're actually solving differential equations. We got all the x's on one side and all the y's on the other, and then integrate. Today, slope fields are helpful because sometimes you can't use separation of variables, and there's a bunch of different methods you could use. We're only going to look at two eventually, but sometimes you can't actually do it, or it's too difficult. So slope fields are helpful because they can help us approximate these solutions. So let's look first at what we mean by approximations, and then we can come back to this definition. So I wrote sketch a slope field for the differential equation y prime equals x minus y for those points. So really, all we want to do is we want to look at, if we make a little coordinate plane there, we want to look at what's the slope doing at these exact points. Again, this is our differential equation, which y prime, that's also another way to say the equation for the slope, right? Let's plug in -1 for x and plug in 1 for y. And that's going to tell us what's the slope at this point. So at -1, comma 1, so at this point here, if we plug those in, you get -1 minus 1, you get -2. So we're just going to make a little sketch of what a -2 slope might look like. Maybe look something like that. All right, let's also put in 0 and 1 and see what is the slope at the coordinate 0, comma 1. So 0, comma 1 is over here. Let's put in 0 minus 1 is -1. So at that point, our slope should be a little less steep, should be -1, something like that. And again, the last one, x is 1, y is 1, so at the point 1, comma 1, well, if I plug that in, 1 minus 1, that's 0. So at that point, my slope is 0. And so if we start like reading from left to right, we kind of see we're starting to get a picture of the general shape of the curve. It's steep over here, it's less steep, and then it bottoms out at 0. We only did 3 points though. This gets a little tedious if you were to do, a 5 by 5 sheet or something, or -5 to 5. Let's instead type in this differential equation into the website there. So dy dx, we said that was x minus y. And this scale, it's going to go from 3 to -3. So if I type that in and do x minus y, well, certainly the computer adds in the slope field a lot faster. And if you look at what we did versus what the computer's doing, well, it kind of looks the same. If this is a scale of 3, over here we said the slope was about -1. Right? At -1, comma 1, we said it was steeper, like -2. At 1, comma 1, we said it was 0. And that's what this graph is showing us, except it's showing us, not every, but a lot more of these iterations. So there's a bunch of these different little dashes because this is a general solution. We're not sure what the exact C value is. So say I wanted to definitely go through maybe this point 0, comma 1, which is like over here somewhere. Well, I can get a particular solution by following the slope field through that point. So maybe I'm following these steeper slope fields. It's bottoming out here, and I'm still trying to follow. It might look something like that. Actually, it probably should look a little further like this. So that's just one. Maybe instead I want the C was like this point down here, which is like 0, -2. If I follow this slope field, well, instead, this particular solution looks something like this, right? It's a bad sketch. But those are all the possible plus C's. Any point I pick, I get a particular solution. So again, if we go back to that definition, which might make a little more sense now, it says a slope field shows the general shape of all the solutions and can be helpful in getting a visual perspective of the directions of the solutions of a differential equation. So let's take a look at another example. Maybe you try. So I have 3 different slope fields, and then I numbered them 1 through 3 different differential equations, or equations for the slope. Why don't you take a look at each one and see which one is showing the differential equation for each of these slope fields. So pause and then check to see if we have those same answers. All right, so one thing I might check is start putting in some numbers. If I put in, I'm just picking, let's put in 0, 0. If I put in the point 0, 0, well, I get 0 here. So that could be this 1 could be A. But the problem is if I put in 0, 0, notice there's only a 0 here. But if I put in 0, it's also 0. And if I put in 0 here, I also get 0. So maybe that wasn't the best point to put in because they end up being the same slopes at 0, 0 in each graph. Well, let's find an easy graph where maybe they aren't all the same. If you look at, well, doesn't really matter. Let's just pick a random point. Let's pick this point instead. Let's do 0, negative 1. Well, if I do 0, negative 1, I get a slope of negative 1. Well, that's a slope of 0. 1 is definitely not A, so I've ruled that one out. Well, let's come over here to this one. If I put in 0, negative 1, also there's no point here. There's no y, so I put in 0. Do I get 0 out at 0, negative 1? No, that's a negative 1 slope. The problem is I have the same slope over here, so maybe also that wasn't the best point, but at least I know that 1 is not A. All right, we could choose another point. Maybe let's start putting in numbers into x. So if I put in a 1 for x, I'm saying that the slope everywhere should be 1. All right, so at 1, the slope everywhere should be 1. Well, that doesn't look like that. If I come over here, 1, well, the slope at x equals 1 is not all 1. But look at this curve. If I put in a 1, notice I have a 1. I have a 1 here. I have a 1 here, like a slope of 1. So that's what A is matched to. A is 2. We could also try the same kind of idea with y. No matter what y you put in, your slope should always be that value. So if you put in 3, actually that's bigger than our graph. Let's put in, again, it doesn't matter what you're putting in. If you put in negative 2, the slope at negative 2, at y equals negative 2, should be that value. So if I go over to negative 2, negative 2 is over here, I see everywhere on that line, the slope is negative 2. If I had put a negative 1 in, everywhere on y equals negative 1 is negative 1. If I put a 0 in, 0. If I put a 1 in, everywhere is 1. So C matches with 3. And then lastly, well, you could probably guess, but again, you could put in points if you want to. This curve here is going to be 1. B is going to be 1. And you could pick some points. If you wanted to put in, say, negative 1, negative 1, well, you should get a slope of negative 2. So at negative 1, negative 1, do I get a slope of negative 2? Let's say negative 1, negative 1. Yep, that looks like a slope of negative 2. Great. All right. Let's try another question. All right, see if you could set up a quick little slope field for that differential equation. You don't have to fill in the table. The only reason I did is it could help you organize it. You know, if you're looking at 0, 0, well, if you put in a 0, 0, well, what should your slope there be? Well, 0 plus 0 is 0. All right, so I did your first one for you. At 0, 0, your slope is just 0. Try a few more. Pause and then come back. All right, well, if you put in some other points, maybe you did 1, 1. Well, if you put in 1, 1, you're going to get 3. So at 1, 1, which is over here, you're going to get a curve that's kind of steep. Maybe that's 3. Again, these are just, sketches. If you put in 0, 1, well, that's going to be 1 at 0, 1. So 0, 1, your slope is 1. Right? If you put in 0, 2, well, your slope is now 2. It's a little steeper. And again, this is 2 and this is 3. Is it perfect? No. So you can do a bunch of these points, and you could check if you want. Plug it into that website that we just used. If we go back to that website, drag this down here. Let's put in our slope fields. 2, and you need this little times. 2 times x plus y. Let's see what this sketch slope field looks like. Oops, let's erase. Sorry about that. Let me erase my... how do I erase these? Reset. Good. 2 times x plus y. So that slope field looks something like this. And again, if we look at the points we did, at 0, 0, yes, it's 0. At 0, 1, does it look like 1? Well, let's check. At 0, 1, sure, it looks like about 1. At 0, 2, does it look steeper? Sure, it looks steeper. So again, you could check your own individual points if you want. But the main idea is sketching a slope field isn't that hard. It just takes some time, a little tedious. That's why it's nicer to have the computer do it for you. All right. And one last just little look at a particular solution. Again, if we go back to that picture of the slope field, these are all the different possibilities of those different plus c's, all the general solutions that it might be. If I wanted to go through a particular point, like for example here, I wanted to go through the point 1, 1, well for this slope field of all these different possible solutions, if I wanted to go through 1, 1, which is right here, I need to follow the slope fields from that point. So I'm following them, it's getting steeper, or sorry, less steep, it's about 0 here, up, and then it starts to get on my negative slope over here. Right, that's one particular solution of all the general solutions that go through 1, 1. So that's all we mean by a particular solution. All right, so for today's class and homework, I want you to practice a few of the slope field ones, just a couple because they do get tedious. And then from the last two classes, we need some more practice on solving using separation of variables. So I've posted the answers to all these so that you could check, you could work with someone else. And we will continue along our merry path next time. Thanks.